Okay, merhaba arkadaşlar. Hope the exam was okay for you. I don't think it was hard, but maybe you had troubles with some of the questions. I don't know. Any questions about the midterm?
Yes, double array. Yes.
So the two-dimensional array question. The question was I don't remember exactly. What was it? But we have a method that you were supposed to write a method, right? So public, and then what was the name of the public? Was it returning something? It returns an array of integers, right? Is it a static? Was it a static method? And then occurrence. Was it static or not static? The method call was with this class's name, then it was static. If it was an object, then it should be not static, right? And then you had a doubly two-dimensional array A or whatever, right? And then int x. So, we have done examples similar to this one. So you would have a doubly nested for loop with, for int starts with I, right? 0, and then you will have I less than, what are we going to say? A dot length for going through the each dimension, right? And then you will have I plus plus. And then within this loop also you're going to have another loop, right? To indicate for int j equals 0, and then j is less than what? AI to get the corresponding row's length, AI dot length, which will give you, if you have a ragged array, right? So something like this, let's say. If this is the structure that you have for array A, then you will check the length of the corresponding row by AI dot length, and then you will have j plus plus, right? So what are you going to check? So if x equals, in this case the second argument was x, AI j, then what you're going to do? You will increment the counter which is kept in what was the so we will have an integer array int, let's say array result, right? Result, what will I increment here? Result I by 1. You may want to initialize the integer array initially, so obviously you will have to, start it with new int. What will be the size of the array that you're going to have? So for each row you're going to have one entry, which means you need to keep track of the length of the first dimension of the array, which is just going to be a dot length. And also here you will just increment those by going from the first row all the way to the last row. Okay? Any question? Does everybody understand what's going on here? How many of you were successfully did this? Okay. Any other question?
En sonda bir base class'ın array'ini oluşturuyoruz da içine atıyoruz. Child class'ların A1, A2, B1, toString'ler var. toString'leri yazdırıyoruz.
Okay.
Onda döndüğünüz o şeylerin yani base class türünden bir array oluşturduğunuz zaman toString dediğimiz zaman hangi toString'leri çağırır? Şimdi child class'ları tanımladınız sonra onu base class'ın array'inin içine attınız. Child class'ların toString'ini mi çağırır yoksa base class'ın toString'ini mi çağırır?
It will call the child class as toString if you have defined a toString for the child class. But we have to see the question and answer it, so I don't want to confuse you there. Okay, so if there are no additional questions, I will go into the slides back and continue from where we left off. Okay. So with the if you want to see your papers once they are graded, you will be able to see the solutions also. So if you have questions at the time, you can ask them while you are checking the solutions as well. So you have other chances to see them. But if you have specific questions, we can talk afterwards also. Let's continue with the polymorphism. If you remember, we said that polymorphism is possible in two ways. One was using inheritance, where you have a base class and a subclass that you can choose the corresponding method from, either the parent's class or the child's class. Or alternatively, what you can do is you can use interfaces to implement polymorphism. How you can do that? We gave last time this example. So if you have an interface that is called the speaker, and then you can identify a guest object that is type of speaker interface, and you create this object by calling new philosopher. And in that case, guest.speak, if both the philosopher and the dog is performing the speak method of the speaker interface, then in that case you could, whenever you call guest.speak, basically you're referring to philosopher's speak method, as opposed to when you say guest new dog, you're referring to the dog's speak method. So we mentioned there are two types of polymorphism. One is using inheritance, and then the other one is using interfaces. And if you look into this, this is really powerful, and we will see how powerful this is in sorting. So let's go over, I'll just really go briefly over the sorting. And as we said, there are many algorithms. I will show you some example algorithms visually as well on a web page, so that you can visually see how different they are. And if you look into the sorting, the idea is to sort things out in a certain order, either ascending, descending, whatever your sorting criteria is. Based on that, your algorithm will sort things. And the main sorting algorithms right now we're going to deal is selection and insertion sort, and then we will, towards the end of the semester, we will also deal with merge sort and quick sort as well, which are dealing with recursion. So we will see recursion, and then we will go into the two types, merge sort basically, and then quick sort, that are doing sorting recursively after that. So if you remember, what we are trying to do is that in selection sort, we are selecting the corresponding minimum element and then putting it into right proper place. Or you can do this for maximum to sort out, for example, for descending sort algorithms as well. So we find the next smallest value in the list, and then successively perform the same task over and over until we finish sorting the whole list. So if you look into the example, this is basically the same thing, so I'm not going to go over it. Basically, you select the minimum 3, put it here, and then you look into, you find that minimum is 1, and you put it in its correct place. The next minimum is 2, it comes here. The next minimum 3 comes here, and then the next minimum 6 comes here, and you have sorted the array by performing the selection sort. So each time we select the minimum one, and we mentioned the swapping also. So once you are swapping two things, you need to have a temporary element, right, as we did before. So you keep track of the element that is going to write onto by using a temporary element. Temp equals first, and then you equalize second to first, and then second can now copy the original value of the first by using this temporary element. So that was the swapping procedure, and this is used in almost all sorting algorithms. And in how do we use polymorphism in sorting is basically we use the comparable interface, so that everything that we are sorting will depend on the comparable interface. If they are implementing the comparable interface, then we will be able to sort them out, because they all have, because we know that if it implements comparable, it definitely has to have the compare to method, in which case we can use it to sort these out based on the compare to method that is implemented by the class. So when you look into the comparable objects, that could be people, books, whatever you choose from, you can sort them if they're implementing the comparable interface. So if we wanted to implement the selection sort, we do not care about what actually we are sorting once we implement the correct compare to method. So let's see the phonelist.java, and then we will be able to write the corresponding selection sort algorithm for this. So let's go and phonelist.java. So when you look into this, it basically uses context. So let me open that too. So here we have a class contact that implements the comparable interface. And you have a public contact, which is the constructor with the instance variables created with the constructor initially. And then the toString method is going to return a string, that is the toString method, as we all know, with the name, last name, and the phone number. And then there's an equals method, which basically checks whether this object is equal to, this contact is equal to the other contact. As you see, it takes an object parameter as argument, right? Here it takes another object, and then since it is type of object, you need to, in order to call its method, the contacts method, you need to cast it to contact, because not all objects have this get last name method. Only this contact class has this get last name method. So you have to first cast it to contact type, and then this object, that it's referring to a contact object. And after that, you can call the get last name. And similarly, if the last names are equal, and then also the first name equals the past argument's first name, then you can say that they are equal. So it's going to basically return true if both of them are equal, first name and last name. And similarly, you have the compare to method. If you recall, compare to method, the way in the interface that's written is, let me open the interface so you have an idea. So if we go check Java compare to, so let me find that compare to. So if you look into the definition of the compare to interface, it's basically public int compare to object O. So this is the way the interface is defined. So it takes an object as an argument for the compare to method, and that's why we have here an object of an other object which is going to be compared to what you have currently in the object. So the result is going to be kept in the int result value, and then you get the other, the past arguments, first name by casting it again to contact, and since this is an object, you need to cast it to contact, and then you can use the get first name, and then you get the last name similarly to the other last string. And the next thing that you do is, if last name equals other last, if the last names are equal, you are going to check the first names by comparing the first name with the other's first name as strings, right? So you compare the first name strings if the last names are equal. However, if the last names are not equal, you're going to get the result based on the comparison of other last name with the last name of the current object. So if if the comparison returns a negative value, result will be negative value. If it returns 0, the result will be 0. If it returns positive, the result will be positive. So basically, it's comparing first the last names and then the first names, and according to that, it sorts them out, and based on the result, you get whether one name is, one person is bigger than or smaller than the other one. So the idea is, in terms of lexicographic order, the last names first and then the first names, right? So that's what is done here in the compare to method. Okay, any question? Basically, it compares as strings the last names and the first names, and whatever is returned by the strings here, it could be negative, positive, or 0 based on the comparison. So the result, an integer, will be positive, negative, or 0. And this is going to be used in comparing to contact objects. Again, where we need to have this because it's implementing the interface comparable. And when you look into the other methods, we have get first name and get last name, which we have already used in implementing the compare to method. And when you look into the phone list, you see that we have an array of contact friends, which is composed of 8 contacts, and you add all of these contacts with these corresponding names. And as you see, they're in different orders, right? So they're not really sorted here. They are just added arbitrarily onto the list. And then it's called sorting.selection sort friends. So basically, it is calling the selection sort for this array, and it sorts the friends list and then gets this result and prints them on the screen one after the other one. If you wanted to implement this selection sort, how can you implement it? So if I want to implement the selection sort for a given comparable object list. So as you see, it is passing as an argument to the selection sorts, the friends array, which is a contact array. However, it's of type, it's of type comparable. So you can basically, since if you look into here, you see that it implements comparable. So if I create a method that is going to sort any comparable objects, I will be able to use this to sort the friends as well, which is a contact array. So if I wanted to write a code for, let's say, public, okay, and then I would like to, let's say, return the comparable array as a result of this. So I will take comparable array and then return, let's say, selection sort. And I will have an array of comparable elements. Okay? And then, let's say, this is going to be the method call. So how can I sort these? I give a comparable object array, in this case contact array, for example, and then I will sort them out and return it as a result. So how are we going to sort a given array of elements as given as comparable? So basically what you have to do is that if you remember the selection sort, right? So what you're going to have is that you're going to have an outer loop. Let's say I have, consider the integer values 9, 3, 1, 6, and then 5. So what you're going to do is you're going to have an outer loop which is going to iterate on the element that you're going to inserting the minimum one among the remaining lists. So you're going to select the minimum from this list and then put it into here. So this is going to be the index that you're going to iterate on for inserting into the current position that you're going to insert the element. And then you will have another loop that's going to check for the minimum among the lists. So basically you will have for int I equals 0, right? And then you will go I less than the number of comparable objects here. Let's say we give comparable x as an argument. So this is the array of comparable objects that I'm going to compare. and then I will say x dot length, right? And then I will have I plus plus. However, obviously, if I reach to the end, I don't need to really do an additional sorting because I will be over. So we probably need to add a -1 here, but we can delay it for now and do it when we come back. And then I will have another for loop, right? So that I'm going to iterate on and find the minimum among the list. So in this case, I will have, let's say, int j equals, where am I going to start with in the selection sort? So we will start, if I'm going to insert here, right? If I'm going to swap with this element, then I need to check whether this is whatever the minimum is here. I'll need to put it, starting from this point on, because I know that the first part is already sorted so far, right? So let's say the next step here is, what's the next step? The thing I'm going to do at the first step is that I will find the minimum here. So I found this. I will do the swap, right? So it's going to be basically 1, 3, 9, 6, and then 5 in the selection sort. So I know that this part is already sorted. And then my next insertion places come to this point. So I will find the minimum among these and then insert it into the second position, which my pointer points to. So I will search among these, which is 3 is the minimum. So it's going to, start with the next element that I'm starting from. So I will start with j equals I, such that, because I know this part is already sorted. So the next thing I will do is I will increment I by 1, since I have 1 and 3 here, and then my I points to this position, and I will search among these 3 elements to put whatever I need to swap. I will choose and insert it into this position because I already know this part is sorted. That's why I start with j equals I, right? So I will search among these, and then I found out that 5 is the minimum, so that I will put 5 here and then swap it with 9, so 9 comes here, and then we swap these 2 so that this is the new structure. And then when I come to the next step, what do? I know that 1, 3, and 5 is already sorted, and I need to select my I points to here, and I need to go and select which one is minimum. So this is the internal for loop which selects the minimum among these 2. Right? This second loop does the selection among the remaining list. So I'm going to select this 6 as the minimum, and then I don't need to do any swap because it's already the minimum, and it will remain there. Since the last element is already sorted, I don't need to do an additional step here. So as you see, this is the outermost loop, 1, so I equals 0, I equals 1, I equals 2, and then I equals 3. And I don't need to go and do the last 9 because that's the only left element, which must be the maximum. So that's why I have, instead of length, I will go all the way to x length minus 1. X length is, going to be 5 minus 1, 4. So I is less than 4 is going to be my condition, so that it will go on only up to 3. Okay? So this is the outer loop again, and then in the inner loop I will have int j equals I, and then what will I have? J is going to be less than, again, x dot length, right? I will need to check all of the remaining entries when I'm sorting, and then I will have j plus plus. So once I find the minimum, so among the internal things, what do I need to do? I need to find the minimum among the remaining list. Here, for example, I need to find the minimum here. So what will I do? I will check with starting j equals I. I will find the minimum. If my minimum, is greater than the current element, which is going to be, in this case, x what?
J.
xj, right, since I'm iterating on j. Then what am I going to say? Then xj must be the new minimum. So I will say that. So I will say that position is equal to j, the new position, and then the new minimum will be xj, right? So basically, once I find a new minimum, I will update my minimum as I go from the list. So if you start with this, in this case, obviously it's not going to find any other minimum, so it will remain here. However, before start this for loop, what will I need to do? I will need to assign my minimum, right? What am I going to assign for my minimum? Int min is going to be equal to the current element, which is going to be xj or xi, not xj, obviously j is not defined here, xi, right? So that I start with the first element to be the minimum. So I will say that, hey, my minimum is 5, and let me see if there are any other minimums, that's smaller than this value. And I will compare it one after the other one. And then position is going to be set to what? I. So once I search through the remaining elements and found the minimum, in this case, let's say this is not a good example. However, let's look at this one. And I found that 5 is the minimum among these 3 elements. So I will find that 5 is the minimum. Then what do I need to do? I need to swap 5 and 9 between each other so that I will rearrange the things. How am I going to do the swap? Basically, you will just use the position and the current I value to swap things, right? So what you will say is that you will say temp equals, remember the swap procedure, temp equals, what am I going to say? I will say xi, so that I stored this 9 in temp. So my temp now has 9 in it. And then I will say that xi equals, what am I going to say? I know that position indicates the minimum one among the remaining lists. So I will say x position. And then what will I say? Now I stored 5 in here. I copied 5 in there. And then the last thing you need to do is that x position is equal to temp. So that now I copied this temp 9 here and I swapped those 2 elements. Exactly, that's a good suggestion. So your friend suggests that why don't we start j I plus 1 instead of going through I again, because you're comparing it with itself. So it's a good logical suggestion. So we will start with I plus 1 and we don't need to compare it with itself and just do an unnecessary thing. Okay, so once I have this loop, it's going to basically compare the minimum with xj. If you look into this, obviously this is not supposed to be an integer value. Why? Yeah, the array is a comparable array, so I should have declared this as a not integer but a comparable object. Okay. Any other problems? Do you see any other problems here? That's good as well. So I'm going to, instead of min greater than xj, if you're using integers, that's true. But if you're using the comparable object, what you need to do is that instead of an integer comparison, you have to have a compare to method, which means you're going to have, how am I going to compare these 2 objects? I will say that I will compare, since my min is a comparable object, min compare to xj, right? And this is going to return me an integer, whether positive, negative, or 0. If this is less than 0, then if it is greater than 0, then I will say that this minimum is not the minimum, xj is bigger than that, in which case xj is smaller than that, in which case I will need to do the swap. Okay, so since we initially wrote this into using integers, it wasn't correct, but you have to use the compare to method in order to implement it correctly with the comparable objects. Any other problems in the code? Okay, so again, the outer loop iterates on the current unsorted part indicates which part of the array is not sorted, and then the inner loop finds the smallest among the remaining list, so that you iterate over and over. And as you see here in this case, what's the running complexity of this loop? So if you have n elements in the comparable array, this loop is going to iterate n square times, approximately. And then this loop is going to also iterate n times, so that, this will iterate n times and this will iterate n times, so that the whole thing will iterate n times n square times. So this is showing the complexity of the algorithm that you have written. So for n elements you will have O(n) square comparisons.
İçerisinde de bir kompleksiniz orada. N kere de onun içerisinde sadece C'yi dönmeyip bir de onu yaptığınızı hesaplamayacak mısınız? Çünkü bir de kıyaslama yapıyorsunuz ya sadece.
Okay.
O da kompleksiteye girmez mi yani? Hem doğrudan geldi.
What we mean here with the complexity is that for n elements, how many iterations you are going to have. That's giving the number of instructions that you're going to perform. This is going to be what you are saying is right, but in that case it's going to be n square, either 5n square, 9n square, 10n square, or something like that. It will be multiplied with a constant. That's what it is going to change, right? So basically it depends on how the sorted array was. Obviously, if it is already sorted, it's never going to execute this part and just execute the remaining swap procedure, which is not going to give you anything else but the initial array. So basically n square indicates how many elements, how many iterations you are going to have based on the number of elements in the array. In this case it's going to be n square. Number of, the complexity will be n square, and you will have n square operations to perform here. So if you look into the implementation of this sorting, so as you see, it public static void selection sort comparable list. It's not returning the list, but it's returning a void in this case. They have written it that way. And then int min, and then you have comparable temp, and you have the outer loop as we did before, and then you have the inner loop that's going to search for the minimum and then perform the swap operation at the end. So this is basically doing the same thing. However, if you consider the other sorting algorithm, which is the insertion sort. So let me show you this, kind of applet which performs the all sorting algorithms. So in insertion sort, pick any item and insert it into its proper place in a sorted sublist. Repeat until all items have been inserted. So basically, instead of going and sorting things, what you do is you select the next element, insert it in its correct position. In this case, how are we going to iterate on the insertion sort? If I have something like this, 93165. So 9 will obviously remain in its place, so I don't need to start with that. I will start with this because it's only element, so there's no insertion there. So 9 will be there, and then I will insert next considering 3. Where am I going to insert it? So I will see that it needs to come before 9, so that I will have enough space for 3 and insert it in its correct place. Now it's going to be 3, 9. And then I come to 1, and I will insert it in its correct place, which is the first part of the array. And then I will insert by creating space for 1. I will make it something like this. 3 comes here, 9 comes here, and then 1 will be inserted here. Next comes 6. I will consider 6. Where is it going to go? It needs to go in before 9 and after 3, so it's going to be something like this: 1, 3, 6, and 9. And then, obviously the last element will be inserted again, in which case it will come here, so that you will have enough room for that. You will switch or right shift the others to the right to make room for 5, and then 5 will be in its proper place: 1, 3, 5, 6, and 9. Okay, so this is how the insertion sort works. It has a different, idea, but it's at the end sorting the same thing. And if you, look into, let me show you the. So this is the similar example. So you start with 3, 9, and then 3 you don't need to care. 9 comes in since it's already in its place, it will remain there. And then 6 comes here so that it's sorted now. And then when 1 comes, it comes to the beginning, it's sorted. And then when 2 comes, it will come to here. You insert that into correct position and it's sorted. So let me do a little video of or applet of the sorting routines. So this is a sort applet. And you can choose, different sort algorithms. So let's go with the selection sort, and it's going to basically start with the max, and then go all the way and select the one that's corresponding. Find the largest item. In this case, it's sorting in descending order, and then it's going to put it in its correct place. So this is the selection sort algorithm. So this is also written in Java, and as you see, it's going to go over things. So I made it faster such that this is just an applet that's written in Java. So if you look into the insertion sort, basically it selects the current sorted list and then inserts the next one into its proper place, as I said earlier. So it inserts into the correct one. Now it's going to insert this in here, so at the beginning, by shifting things to the right. I think you get the idea. If you make it faster, obviously. As you see, there are a lot of shiftings that's happening in the sort, so you have to shift a lot of elements one by one in order to get the result. So let me show you the bubble sort, which is similar to these. So basically, it's bubbling up the largest item to the to the maximum position. So it basically compares it with the rest of the elements and finds the maximum and bubbles it to the top of the list or end of the list. So it compares those two. Now it's the maximum. It's going to go forward. So now once it's found this biggest, it will continue with the next biggest and find the next biggest element and then put it into the correct location. This is called bubble sort. And I will show you just just to see how the recursive ones, the merge sort and quick sort, also operates, but we are not going to go into discussion of those. I will come to them later towards the end of the semester. So we will see merge sort. So merge sort basically divides things into two pieces at every point, and then as you see, what it does is that it sorts these two, and then it sorts these two, it sorts these two, it sorts these two among each other. So it is sorting basically two elements at a time, and then it knows that this list is sorted, this one is sorted, this one is sorted, this one is sorted, this one is sorted, and then these two are also sorted now. And the next point on, what it is going to do is that it is going to merge things. So it will merge these two lists into one list. Okay? And then since it is already sorted, it will just do a one-to-one comparison within each list and then merge things. Now, as you see, it's going to sort these two lists. This is the merging step of the sort algorithm. and then it's going to take these 4 and sort them. And as you can imagine, in the next step, it's going to basically take 8 of these, because 4 pieces are sorted already. And then it will take this 8 elements and then sort them. So basically you have 2 pointers at the same time, one from this list and one from that list, and find the minimum every time and put it into the next position. What's the complexity of this merge sort algorithm? What do you think? You have to tweak it around in order to, if it is not power of 2, you have to, write the algorithm in that fashion. But, it's not a big problem. It's not going to be as effective as if it is a power of 2, but it's, again, going to be n log n, as your friends said, because in, recursive algorithms, in merge sort, basically, what you do is every time you divide the list into 2 halves and then sort them. So basically what you do is that you have a 2 list, sort them, and then this is going to be sorted in its part, and this is going to be sorted partly. And then you will have 2 smaller lists here. So as you see, every time you divide the list into 2 halves, which gives you a complexity of a 3 log n. So which is going to be the if you have n elements in the list or array, then you're going to have log n height of this 3, which is going to take you n times log n to get the overall complexity. But we are going to come to the merge sort, again, once we're done with the recursion. And if you look into the quick sort, this is again this is again an implementation which is running in n log n, and it has a pivot, which basically, this is the pivot. It selects the smaller elements than this element and then puts them onto the left-hand side of this, and then the elements that are greater than the pivot are placed towards the right-hand side of the array or the list. So basically, it now knows that everything is smaller than this one on the left-hand side, and everything greater than this one are on the right-hand side. Now, this is in its correct location. Now, the next pivot is this one, so it's going to put it in here, and the remaining things that are on the left-hand side is going to be towards the left-hand side of this, and then the others will be right-hand side. So basically, it's finding the this is the pivot. Everything will be sorted based on this, and the ones on the left-hand side will be smaller. The ones on the right-hand side will be greater. So this is again dividing everything into 2 halves. However, not exactly 2 halves, but approximately into 2 halves. It depends on the pivot. If you have a pivot that is the greatest element, then in that case, you're just doing unnecessary stuff, which is going to put it into the rightmost location. So it basically depends on the pivot that you're selecting initially. So pivot selection is the main problem in quicksort. However, on the average, quicksort also gives you an n log n performance. But worst case is going to be n square again. There are, many other sorting algorithms, more than you can imagine. So there's a lot of research going into this. And for example, odd-even sort, parallel sorts, which are parallelized for using multiple computers and things like those, are also implemented. So basically, that's the idea. And again, I'm going to come to the algorithms for quicksort and merge sort towards the end of the course. Any question? So when you look into the insertion sorts algorithm, how are we going to perform the insertion sort? So this one performs the insertion sort for the same comparable array. So basically you have a static void insertion sort comparable array list, and then again you have an outermost loop which is going to basically indicate the current sorted list. So it's going to start with index 1 and then go all the way to the last of the list, and you have a comparable key, and you have the current element in the key and in position kept in index. And while position is greater than 0 and key compared to list position -1 less than 0, you will swap things and then move it into correct location in the insertion sort as well. If you remember the algorithm, every time you move it to the correct location. So if you recall, we had this list, right? So I will have, let's say, 9, 6, 3, 1, 5, right? So my index starts with, the outer loop starts with index 1, right? So I will start with 6, and then I will look into the elements that are left of this this element. So I will check with the left of this element, because I know that part is already sorted. So I will check while position is greater than 0 and the current key, which is 6, compared to position -1, which is, you know, the element towards my left, is less than 0, meaning that 6 is less than 9. So in that case, I will just shift my element to one left position, in which case I will just move it to here, right? Basically, this is going to be moved here with this command, list position equals list position -1, and then I will decrement my position by 1. So that's going to finish my while loop. Why am I going to finish the loop? Because the position is not greater than 0, or also, the main reason is because position is not greater than 0. It is now equal to 0, since it was 1 position. And then next time it's going to be decremented by 1, and then my position will be here, so that I will just have 0, which I won't need to continue. And then list position is equal to key, so I will have list position, which is this one, equal to key, which was my key initially. 6 will come here, right? Next thing, I will increment my I by 1, the index by 1. It was originally 1, so it will point to 2. Now my index is going to point to 2, so it's going to point to 3. Now my key is going to be 3. Key is equal to 3, right? And then what will I do? I will have this loop while position is greater than 0, which is the case, and then my key compared to list position -1 is less than 0. I'm going to compare this 3 with the left of this element, which is 9. Since it is less, I'm going to continue on decrementing my position by 1, and also I will update this list position to, instead of 3 it will become 9, right? And this will be 6, remaining same. And I will decrement by my position by 1, and then next time what is going to happen? What's going to happen next time? So my position is pointing to this. I will compare with the leftmost one, which is 3, so that it's going to just basically swap this here. 6 will come here, and then since my position is going to be decremented by 1, my position will point to this. And next time I will say that, position is no longer greater than 0. I will finish the while loop and come to here. My key is going to be inserted there, which was 3. And then I will continue with the next element. So my index will point here. My key will be 1, right? And then I will compare it with the previous element, position -1. Since it's less, I will move this 9 here. I know that I need to move it to the left so that I create the space. And then I will compare it with the next element. Since 6 is still greater than 1, I will move it here, and then I have this space available for 1, in case it's going to go in here. However, I compare with this, and then I see that it's going to come here, and I insert it to the last position, because my while loop will be over. And then, next thing is what's gonna happen is that you will have 1, 3, 6, 9, and then your index will point here, and then your key will be equal to 5. 5 is going to compare with this one, and then 9 will come here with the while loop, and you compare with 6 since it's bigger, and then you will find that key compared to list position -1, which is position -1 is 3, is not negative, so it's positive, and then you will exit the loop. that will make your list position equal to key, so that you will have 5 inserted here. Okay, so that's how the insertion sort algorithm actually operates in the code given here. Okay, any question? Okay, we'll continue on the next lecture. Let's have a break.